Okay, we'll try this for the second time. Let's hope no fire alarms go off. Right, today we're going to be looking at more challenging problems in terms of volume of 3D shapes. So the first thing that I want to look at, which is recasting. Now, when I say recasting, what do I mean? Well, if we take a shape like this, so a cylindrical shape like this, a solid shape like this, what happens if I melted this shape down to form a new shape? Well, assuming that I would use all of the volume of this to recast this, well then their volume should be equal. Okay, so we're going to look at a problem where we melt down a particular shape to form another. Okay, so the first part we're told is the diameter of a solid metal sphere is 24 centimetres. And we're asked, find the volume of the sphere in terms of pi. Right. If we know that the diameter is 24 centimetres, well then we know that the radius of the sphere is 12 centimetres. Okay, so very simple. The first part, we're just asked to find the volume of the sphere in terms of pi. So you don't need to know your formulas off by heart, but if you do, brilliant. Otherwise, you'll go to your log tables, which will look like this, and get the formula for volume of a sphere. So we can see here the formula for volume of a sphere is 4 over 3 pi r squared. So that's the first thing that you're going to write down. So you're going to say the volume of the sphere is 4 over 3 pi r squared. Okay, so what information do we know? Well, we're asked to leave it in terms of pi, so we're just looking for r. So we know in this case that the radius is 12. So we substitute in the information we know into our formula. So we replace r with 12. And when you pop that into your calculator, you'll get 2,304 pi. And when we're talking about volume, we're talking about cubed. 3-dimensional, so it's going to be centimetres cubed. Okay, nothing difficult there. The second part of the problem is where we recast our sphere to make another shape. So we're told the sphere is melted down. All of the metal is used. So when we say all of the metal is used, well then we know the volume of this sphere will be equal to the volume of whatever shape we make. So all of the metal is used to make a solid shape consisting of a cone on top of a cylinder as shown. So we can see down here, we have the cone sitting on top of the cylinder. The height of the cone is 6 centimetres and that of the cylinder is 8 centimetres. So we can see from here to here is 6 centimetres and from here to here is 8 centimetres. And we're asked to find the radius of the cylinder and cone, correct to 1 decimal place. Now, the radius of the cone and the cylinder will be the same because the top of the cylinder is the base of the cone. So the radius is going to be the same. So the first thing that we want to do here in this problem is we want to get the formula for volume of a cone and the formula for volume of a cylinder. So again, you'll be going to your log table. So the volume of the cone, so the formula for that is 1/3 pi r squared h. And then the volume of the cylinder is pi r squared h. Now, we know that the volume of this plus the volume for this will give us the total of the whole shape. And then we know that that volume will be equal to the volume of the sphere because we use all of the metal of the sphere to recast this shape. So we're going to add these together. So we have 1/3 pi r squared h plus pi r squared h. Well, that's the volume of the cone plus the volume of the cylinder. We know that that should equal the volume of the sphere. So 2,304 pi. In our formulas, we'll sub in the information that we have. Okay, so we know that the height of the cone is 6 and we know that the height of the cylinder is 8. So we'll sub that into our formula that we have. So we have 1/3 pi r squared and replacing the height with 6 plus pi r squared and we know the height is 8. Should give me 2,304 pi. If we simplify this, then that becomes 2 pi r squared. And this will be 8 pi r squared. And that should give me 2,304 pi. Again, if we simplify our equation, we're going to end up with 10 pi r squared h. Gives me 2,304 pi. Now, the pi's will cancel out. So we're just going to end up with 10 r squared equals 2,304. So then, in this case then, r squared will be 230.4 because we divide both sides by 10. And r is going to be the square root of this. So when you pop that into your calculator then, and round it to, we're asked to 1 decimal place, you get 15.2 centimetres.